All right, folks, it's back in action here. On this page of notes, we are going to introduce a few more vocabulary words so that we can, on the next page, actually start solving some equations using our matrices instead of our traditional algebra approaches. So a couple vocabulary words that I have here on the top, I've already filled in the blanks for us. We're going to have a coefficient matrix, and it's going to be a matrix created by just the coefficients of a system of equations, but it's not going to include that constant that we would find on the right-hand side. An augmented matrix, however, is going to include both the coefficients and the constant. So let's take a look here. We're going to write the augmented matrix for these two systems of equations. The things that I want you to notice as we look at these is the fact that we have some missing variables here. So I've got a gap right here, and I have a gap right here. On the other equation here, my other example, I've got a gap right here. And when we did our long division, it was sometimes an option whether we included those zeros or not, but we definitely have to include the zeros for those spots when we go to write these augmented matrices. So when I go to write this, I can give myself my first bracket here, and really I'm just going to grab each of these coefficients and then the constant and write those across the top. So, for example, I would have a 1, and I'd have a 3, a -5, and a 6. Looking at the next one, I'd have a 2. I have to put a 0 in there for that missing spot, my 4 and my 5. And then I'd have another 0 and a 3 and a -2 and a 7. And I can finish off that bracket. The other thing that we'll often see on the augmented matrix is they'll draw in a nice vertical bar here, and it separates the coefficient matrix from the constants. It just kind of helps us separate things out, but you won't necessarily always see that there. I've certainly seen it both ways. On my next one here, I can go ahead and draw my bracket. I'm just going to grab those coefficients. So I'm going to have a -3, a 4, a -2, and a -5. I'm going to put in both zeros, one for the z and a 3, and a 5, and a -2, and a 6, and a 10. Close off that bracket, and then again, if we want, we can draw in that vertical bar, separating the coefficient matrix from the augmented matrix, or from the constants. Now, once we have our matrices in our augmented matrix form, then we can start to look at what are called elementary row operations. So I'm going to kind of give some instructions here, but as you're solving these eventually, you'll have to come up with these row operations yourself. So the way the elementary row operations work is we have a couple options. We could just interchange two rows, just flip-flop them. We could multiply a row by any constant. We don't need that a there. We could multiply any row by a particular constant, or we can add rows together. These are going to be very similar to what we did in our traditional algebra approaches of substitution and elimination. We can perform these three operations to any augmented matrix, and it's going to produce a new and equivalent matrix, okay? Again, as I just said, this is going to be very similar to our elimination method of solving our systems, okay? So let's take a look. On this first one here, I give you an augmented matrix, and I just give you a simple instruction that says I want you to interchange the first and second rows, meaning I just want you to rewrite the matrix with those rows reversed. So I'll have a 2 and a -4 and a 6 and a -2. That's going to become my top row. My middle row is now going to become what the top row was, and the last row stays exactly the same. So all perfectly allowed. So that would be one possibility. Now, on the next step, I am going to multiply the first row by a -1/2. So I can take any row and multiply it by a constant if I want. So I'm going to take my new first row that I have here, and I'm going to multiply all those values by a -1/2. The rest of the matrix is going to stay exactly the same. So sometimes it's nice to actually just rewrite the parts that are going to stay the same first. So we know that we're still going to have the 0, the 1, the 3, and the 4, and we're still going to have the 1, the -3, the 5, and the 2. Then that top row is going to get multiplied by the -1/2. So a 2 times my -1/2 is going to be a -1. A -4 times the -1/2 is going to be a 2. And my 6 times my -1/2 is a -3. And my -2 times the -1/2 is going to be a +1. So that would be another option of something that I could do. On the next page, we're going to do one more row operation, and then we're actually going to dive into solving a system with these row operations.